Our last approach to evaluating limits is graphically, where we are actually coming up with the graph. Sometimes algebra is just not practical, or there's no algebra you can do, no reasonable algebra you can do to figure out the answer, and so substitution doesn't work. And in that case, you might have to resort to either making yourself a table or a quick sketch of a graph, or if you have your calculator, taking out your calculator. So in this type of problem, I'm highlighting the fact that we won't need a calculator for this type of problem. You could use a calculator, of course, but we can get at the answer without actually having to use a calculator. So when coming across a limit like this, of course the first thing you want to think about is, can I just substitute in the 2 for the function? But you quickly realize that you'll just be getting 0 divided by 0, which is an indeterminate form. And so we can't do that. Is there any algebra we can do to maybe get rid of that x minus 2? Not exactly. I mean, the absolute values are a little awkward to deal with algebraically, so we're going to have to shy away from using any algebraic techniques. But one thing we could do is we could just make a table and try to graph this and see what's happening around 2. So let's make a table here. And let's plug in a few numbers. So let's plug in, let's start with maybe 0. When you plug in 0, you get 0 minus 2 in the top, which is negative 2, and then you're taking the absolute value of that, so you get a 2 in the top, and then in the bottom you get 0 minus 2, which is a negative 2, so that's a negative 1. When you plug in a 1, you get the absolute value of 1 minus 2 is a negative 1, is a 1 when you absolute value it, so the numerator is a 1, and then you divide by 1 minus 2, which is a negative 1, so you get a negative 1 again. That's interesting. Plug in, let's plug in 2. When you plug in 2, you get 0 over 0, so we'll leave that as a blank. Plug in a 3. If you plug in a 3, you get 3 minus 2 in the top, which is 1, and the absolute value of 1 is 1, so you get 1 over, and then 3 minus 2 is a 1, so you get a positive 1 this time. Let's try one more. You plug in a 4, you get 2 on the top, and 2 on the bottom, which is a 1. So this is kind of interesting. It looks like we've got a behavior change in the function right at 2. It looks like if I plug in numbers less than 2, like 0 and 1, I'm getting negative 1. And if I plug in numbers bigger than 2, like 3 and 4, I'm getting a 1. So if we were to graph this, what would it look like? Here's 2. And if we plot our points, I got 0, negative 1, 0, negative 1, and 1, negative 1. 2 we know we can't plot. 3 we get 1. 4 we get 1. And so maybe at this point you can kind of anticipate, if I plugged in 5, 6, 7, 8, 9, etc., I would probably still get 1. And you can check that. So it looks like any number bigger than 2 would give me a 1. And that includes numbers like 2.1, right? If you go ahead and look at plugging in 2.1, 2.1 minus 2, absolute value it is 0.1, and the denominator is 2.1 minus 2, which is 0.1, which is 0.1. So you also get 1 by plugging in 2.1. So it's 1 all the way up until 2. So we're going to continue that all the way till there. Whereas if you plug in numbers like 0, 1, negative 1, negative 2, negative 3, you'll see that you keep getting negative 1 for those values. And that includes numbers like 1.9, 1.99, so we're gonna assume, or we're gonna reason that it's gonna be negative 1 all the way up until 2. And so there's my graph. And at this point you'll notice that if I wanted the limit as x goes to 2, well, as I approach from the right, I'm going towards 1, and as I approach from the left, I'm going towards negative 1. So since those aren't the same, this limit does not exist. Limit does not exist. However, if I ask this question, that does have an answer, because we're just approaching 2 from the right. That answer is 1. And also, if I approach just from the left, that has an answer. It's -1. But since these are not the same, that implies that the limit in general, when you're approaching 2 from both sides, since those aren't the same, then that limit does not exist.